So to find the derivative of this, we're going to need there's a couple things going on. First of all, notice this subtraction sign here. It means that I treat each of these kind of separately, but then each of these is a function inside a function. Function inside a function. So I'm going to use the chain rule, and I'm going to kind of treat each of these separately. So dy dx, the derivative of this whole thing, in other words, dy dx, or the derivative of y, is equal to, treat that separately. What's the outer function?
The natural log.
And what's the derivative of a natural log?
It would be that one. So it'd be 1 over...
It's 1 over x squared plus 4 times
the 2x.
Times the derivative of x squared plus 4, which is 2x. Good. So there's the derivative of that one. Minus 1/2, you can just leave out in front of there. And what's the derivative of the tan inverse function? 1 over 1 plus u, which is x over 2 squared.
Times the derivative.
Times, and then I multiply that by the derivative of the inside, which is what? Just 1/2. The derivative of x over 2, it's like 1/2 x. It's just 1/2. Oops, that was too many. Got it? And then let's just clean it up. So that equals, so y prime or dy dx equals 2x over x squared plus 4 minus, now notice that this is like that, right?
Those 2 1/2s cancel out.
The 2 1/2s don't cancel out. They multiply together, right? I can move them around, right? So that's 1/4. And actually what I prefer to do, I guess, is just to leave what's in the numerator. There's just a bunch of ones. Yeah. So 1, and what's in the denominator?
4.
2 times 2 is 4. 1 plus, you can write x squared over 4. You can distribute that in if you want. So actually what you can do is distribute this 4 in now. So clean it up even more. That equals 2x over x squared plus 4 minus 1 over 4 plus x squared. Hey, look what I have.
And then
they're common denominators.
So it'd be 2x minus 1.
So then I can add the numerators, which is 2x minus 1 all over x squared plus 4. And then you ask yourself, does that factor? No. It's close. If it was a negative, it would, but it's not. It's a positive. So there's your answer. And you're done.